Okay, so I will be giving a talk on how to use Git. I can make it more detailed or more generic depending on what's your experience with Git. So before that, who has anyone not used Git? Maybe you can write in the chat, like zero experience or maybe very little. Okay, so I will go from the basics. If something is already known, you can leave the comment in the chat, or if you have questions, feel free to interrupt me. My intention was to deploy an application to Flash, a FastHTML application, and see what Git commands will make it easier for you to develop. This was my plan, but I'm happy to change to whatever is more useful for you. This first slide, the important thing is Git immersion. My slides are more or less inspired by this Git immersion I already shared. It's a quite concise tutorial, and it goes over things that I will not explain, like how to set up your Git locally and other stuff like that, because Git is a very complex topic. So I will just give you a brief overview. I will give the example will assume that you are a solo developer. So we will not focus on how to share code with others. We will focus on how to develop locally for yourself and to make sure that AI or you don't break these changes. A bit history, a bit like what is Git? Git helps you track changes. You can imagine like a Dropbox or a version control that works locally. And you can go to any previous version in time. You can also create alternative versions called branches, and you can safely collaborate with others. If you use it well, you will never lose work again. That will really not happen, and you will eventually fuck up anyway. At least that's my experience in some years of work, but it will mitigate much of the problems that you will have. Git is just a command line tool, and there's the changes need to be backed up into an online service, like for example, GitHub, that I will also explain in the future. A bit of history, I think, is always good. Git was created by Linus. Linus is the creator of Linux. And Git was created basically as a tool to synchronize developers to work on the Linux kernel. So it's fast, it's distributed, and the Linux kernel work happens over all the globe in a very async manner. So it's a very, very powerful tool. And many of the flows that you will use as a solo developer or in small teams are just a brief part of what you can do with Git. You can really do a lot of things. So some terms for people not to get confused. A repository is like what your project is called. And normally we will say repo, because your repository or your project has two components. One, what you are working with locally. And second, let's say the backup that is in the cloud. We will talk about local repository and remote repository. Remote repository, you can imagine the files in Dropbox, and local repository is the files that are in your computer. So there's two copies of them. Commit, a commit is the key synchronization mechanism for Git. A commit is a snapshot of your code at one single point. Essentially, we will say, take all of these files and create a picture of how they look exactly now. And if in the next commit I change a bit the CSS, then we will mark the changes of this file. Push and pull, although we will not do too much. Push is when you send or synchronize the changes that you have in your local repository to GitHub, for example, or to a remote repository. And pull is the opposite, is when you pull these changes. In this case, we will not be pulling because there's no one else changing the repository. But if I'm, for example, collaborating with Aditya, I will push my changes and then he will pull my changes into his local repository. So then there's this two-way communication. I push, he pulls, and vice versa. As I already mentioned, like it's sometimes people get confused. So Git and GitHub are not the same thing. Git is the tool itself. For example, Linux kernel development does not happen in GitHub, has no relation to GitHub at all. As far as I know, GitHub is owned by Microsoft now. And Git runs on your computer, it's offline, and you can use it completely without the internet. So you can always version your files locally, but then you will not sync them up with a remote repository. There are other remote repositories like GitLab, and yeah, there's many of them. Some of them you can run yourself, like GitLab, but GitHub is just a hosted service, and it has some features that only happen in the online service. Like, for example, pull requests, where you ask to merge your changes into, if you are collaborating to FastHTML, for example, repository, you will push your changes into their code base and they will have to accept it. So this merging is part of GitHub or GitLab. It's not part of Git itself.
Hey.
As I mentioned, yeah.
I just had a real quick question.
Yep.
I was just wondering, with respect to, so I'm just kind of joining this meetup for like the first time, right? I'm just like not too sure if there were previous sessions before this or if this is the first one, but I guess I'm just wondering, like, is this a deep dive into specifically fast HTML as a library, and does this go through fundamentals of like HTMX and like other web
No,
development
no.
processes, or is this more just on like the library itself?
In this talk, we are just going to, because people did not know how to use in general Git in the community. So we are going to see how to use Git to deploy a very simple application of FastHTML. So you will see FastHTML, but I will not be explaining FastHTML per se. I'm happy to explain that if it's needed, but I think that the main focus was to see how to use Git and GitHub with FastHTML.
Okay, no, that's all good. I guess I just wonder, and I guess I don't want to derail the whole thing. I'm just wondering, is the Git knowledge, is that disconnected or connected to the fast HTML stuff? I guess I just wonder if that's more general, right? And if that's like a more general skill that can be applied to various different projects, or if that's something that's a bit more applicable for like a fast HTML context.
So Git, I would say that almost any developer that I know about that has been working for a while uses Git or some kind of version control. So Git is only a way to track the changes in your code. And the natural extensions of GitHub is how to deploy things, how to have testing, how to have code coverage. So essentially, when you are in any team or even as a solo developer, Git is what you want to use to keep track of your changes, make sure you don't break things. And if you break things, you have previous versions. And if you want to release things, you use this. I don't know if you were here, but it's essentially used for the Linux kernel development. So Git is a way to develop code and share it. So it's definitely applicable to any development things you do.
But maybe that was my bigger question, real quick, was just like, is the stuff that we'd be learning in, for example, previous in this lecture, would this be would this be more fast HTML specific content, or I guess I more wonder if it's Git specific content.
It's how to use Git for fast HTML application.
Right. And I'm saying that because Git is a bit of a general technology, it doesn't actually have an application specifically in fast HTML, right?
We are trying to learn Git and see it using an example of fast HTML. I guess that's what we're playing, like intersection of.
Oh, gotcha. So fast HTML is the mechanism in which it's being applied, like the general concept, but it's not to say that it necessarily needs to be learned that way. Like that sort of.
Yeah. Git can be used for any programming language, any library, anything. In this specific case, we are going to build a fast HTML application.
Yeah. Gotcha. All right, cool. Thanks. That's all.
Okay, so I have some slides, but I think it's easier if we do live here already. So first of all, you will have to install Git. If I do Git status here, you'll see there's not a Git repository here, okay? Git in general over the years has become very, very good with the documentation. So if you read what Git is telling you, you will learn much, much faster. So I really suggest to read this stuff. So if you want to create a new repository, you just do git init, and it will tell you, okay, we have a new repository in this. If I now do git status, it will give you already a lot of information. We are on branch main. Branches are ways to keep parallel changes, let's say, but for now we will not get into this. Let's say we are in our main branch. There are no commits, as we said. It's a new repository, so there are no changes so far. And here it tells you, okay, there are some files that are not tracked. So Git is telling you, I have seen some files here, but I am not tracking them. So if we want to do our first commit, the only thing we need to do is git add. And we will add main and this style CSS. And this would be your FastHTML application. And the style CSS is just a placeholder. You can also add the requirements, which is just the dependencies. Okay. The way to do this is just do git add, and if now we do git status, it tells us, okay, these are the changes to be committed. And it just tells, I have seen 3 new files. And if you commit, these changes will become the first snapshot. So now I can do git commit. -m is the shorthand for message, and we will call it initial commit. Again, this feels like a bit esoteric, but it's like just telling you that we are in main branch. This is the hash of the commit. So each commit has a unique ID. And this is the name of the commit. And it just has a summary, like there's 3 files. And create mode means that we just added this file. There's no deletion, there's no changes. Questions so far?
There is one question in chat.
The file has to be added in this commit, yes. Otherwise, Git will not add anything because you can have files that you do not want to track, for example.
And also Manasi had another question. So unless I commit, my file is not backed up in Git.
No, exactly. Well, there's some caveat to that. So now, for example, if we do git status, it will say there's nothing to commit. The working tree is clean. The working tree is like how it calls the git status, because it's actually a graph where you have one commit after the other and it can become a tree. We will just explain this a bit later. But now if I do a change, let's say I want to debug HTML events and I uncomment this, right? Now, if I do git status, it will tell me, okay, there are changes in this file, but they are not staged for commit. So here we can use git diff, which is another command. And it will tell you, okay, you remove this line and you added this new line. This is important because Git only tracks changes at line level. It tracks only lines. So you can either add a line or you can remove a line. You cannot do anything else. So if you are being coding with AI, you will recognize this format from Cursor. This is using the terminal, but if you open the Git IDE stuff, you will see exactly the same. See, this is in red, this is in green. You have seen this in Cursor maybe, or using AI when it proposes some changes? Okay, so it's essentially a Git diff. It just tells you the lines you remove and the lines you added. Answering your question, yep.
Yeah, so I have a question. When you say line level, so if I change the whole code, like what do you mean by line level changes only?
So it means that if I do, how to explain this? So it means that Git will take your file, it will split it into lines, and then for each line number, it will say, is there a change here or no? Have we added something or not? The way Git works is like, the first time you add a file, it will add the whole file, let's say all the lines. And then in the next commits, it will not copy the whole file. It will say like, hey, from the previous version, we added 1 line. From the previous version, we removed 1 line. So that way, it doesn't have to keep track of the whole file. It keeps track only of the lines changed.
Okay.
The downside of this is that when you have binaries, like for example, images, Git is not able to track images properly. It will say like you change the whole file every time, even if there are some stuff because it's a binary thing. So it's not ideal to upload things to Git because it cannot tell you which line you changed. Every time you change an image, it will have to save the whole image. And then your Git repository will explode in size and it's going to be very slow. But this is a bit more advanced. But it's good to know that that's what is important because it always will track the changes line by line. If I change here, it will say, okay, these lines have been changed. But if I now duplicate this, See, it will say, okay, what happened? You actually removed one line, you converted one line in this, and you added a second one. So this line is no longer matched to both. It just, in line 8, there was a deletion and an addition, and additionally, there was a new line. Does this make sense? It's a bit tricky, but this you get used to it.
Yeah, understood.
Okay, so answering your question, Aditya, the first thing that is useful is that now we have an initial version, and Git knows what was the initial version. So imagine now somehow the AI does something I don't like, right? And I have some error. Now here it's very easy to see, but if the file is very big, sometimes maybe you hit that key, there's some problem, there's some error, and you say, okay, I don't know what's happening. I want to revert these changes. Okay, so now we see here we have this error. So if you read here, it's telling you, if you want to discard these changes, you can just do git restore file. So if I now do git restore main.py, we can see here that the changes disappear. And the git, if you do git status, is clean again. The way this works is like Git actually modifies the file system for you. So all the programs that are looking into this file system will see different things depending on the version of Git that is active, let's say. Is that clear? Okay, so let's see what else. The status, yeah. So there's another useful command, that's git log, and it will show you more details. Now it only shows one commit, but eventually it will show one commit after the other. And again, if I am more comfortable with the command line, but all of these things nowadays can be done through the IDE. So if you go here, you will see the same initial commit, and it will even tell you what happened. This is the initial commit by Pol, 3 files, and added. Okay.
So is it an extension, the left side graph, or?
Yeah, it's this one is a Git lens, but I think that more or less all of them have either native or some support. This one, I think it's Git lens, if I'm not mistaken. Git lens, but I think it's by default, honestly. I think you don't need any extension. I think this icon is already there. I have Git lens because, for example, it allows you to see this shadow text here. This is very convenient when you are checking other people's code, because you can see, oh, who did this piece of garbage code? And then you know who to blame. Normally it's you, but then you don't say anything. Or yeah, it's useful. Or when did I change this? And then you see when it happened. It's very convenient. And this is Git lens. Okay, so Git we saw this. Stage changes, we saw this. The staging area is this place where we put changes, where we add changes before we actually commit. And when we restore, we remove things from that staging area. Okay. We saw the commit, view history. Okay, so let's actually do a second commit, and we can see this. So now we have, again, a modification of main. I add the main, and I say, sorry, I have some shortcut. There's a lot of shortcuts. Every person has different shortcuts. Git immersion have good ones, which is the ones I use, but there's a lot of them. So the back stuff. Now, if we do git log, we can see that there are 2 of them already. And this head, the word head means what you are going to see in your file system. The head is where what your file system will view. So now, for example, if I want to explore another commit, like this one, I can say, hey, I want to check out this commit. It will show you a warning saying like, okay, now we are in a different commit that is not the normal one. See? And if I do this other command, I'm sorry, I have some command, but now you can see this is the first command, this is the second command. And here it tells you the head is actually pointing to the first command. So once again, this script is commented. Does that make sense? This is like a very good way to check, oh, how did I do this in the past? And then you can quickly check your code in the past without modifying your current code.
So is it possible to go to all the versions that we have changed, like from like version
Yes.
1, version 2, version 3, all the versions we can
Yeah,
see
you
what
can just use the commit, these commits, and then you can move. So now I can go back to my normal version. I will tell you previous head was in this commit, which was the initial commit, and now the head is in this commit, which is debugging stuff. And this is once again not commented.
What does the head means?
Head is just the way of Git telling what will you see if you look at the file system.
Okay. Mhm.
Okay, everything, all that Git does is in this repository, in this folder, .git. This you should never delete. If you delete this, all your changes are gone. Or like the files here will be left as they are, and any changes will be lost. So do never delete the .git. That is where the magic happens. This is, if I delete the Git now, well, I can do it because there's not anything. But if I do Git this, now suddenly I do Git status, there's no Git anymore. Makes sense? And I cannot recover these changes, no way. If you have not pushed to a remote repository, it's gone.
right.
But the files in the file system are not modified. So now I do git now again, and I can just add the main and the style requirements. And now we are back with one commit. Something to note is,
Yeah. So when you're adding style CSS and other files also, so if you make changes in those files, does that also make versions of it and commit those files as well to Git? Or is it just the main.py file?
I didn't get the question. Could you repeat?
I mean, if you make changes to suppose style.css file, it's in the Git folder. I mean, it's also committed to the Git, right? I mean, or
Yeah,
is it just the main file?
If you commit, yes, then this .git folder will keep track of those changes.
Okay, but I'll have to commit the file, like the file itself.
Yes.
Okay.
So now this new commit, actually, if you check when we went back, you check out 1, 6, or any of these commits is different from the one we have now. And this is a bit more advanced, but it might bite you back in the future. So it's a good moment to say that each hash is computed from the previous commit, the contents, and also the timestamp. So you will never be able to commit the same commit twice. The ID will always change. And this is important because if you are, for example, you do 5 more commits and then you say, oh, second commit was wrong, I need to change something there. You cannot do that. You need to completely remove all the commits up to that point and then redo the history. There's no way to go back and change the ID because all the IDs go back after it. It's a bit like a blockchain because it's a way the hash is computed from the previous hash and the current hash. So each commit is completely linked to the one before it. And that's it. That's the only way that Git knows who comes from where and builds a graph. Okay. We already did this. Okay, this is a good schema that I think will put things in place. So workspace is your local repository. Whenever you add a file, it will go to this staging area that we said. All the files here will become new changes. And this is a bit counterintuitive because, for example, now let's say I do not want this anymore, right? And I want, let's say, create some wild styling for my application. We will use Cloud Code 1 second. The last time I asked for styling, it was horrible. So let's see this time. So the point I wanted to make is that this staging area, now main is in the staging area, right? We can see this. But what is in the staging area actually are the changes that I added. So if I now change the demo Git workshop, I add something else. Now suddenly I have main is in 2 places. And this might be a bit confusing before because there is one change that is going to be commit, but I can keep working on it. So this is a good way to say like, okay, I think what I did is okay. So I have it pending for commit, but I want also to add the style CSS, for example, but I don't really want to commit yet. So that way you have the file in the two places at the same time. Is this all right? Okay. So perfect. So let's actually add some styling. And let's add other changes. You can do git -u, which means add all the untracked files. You don't have to remember all of these things. Some of them will come naturally when you need them, or if you check git immersion. So second commit, and now to run this, you will have to create a Python environment. If you don't use virtual environments, I suggest you learn how to use them because it's very convenient. In my case, I have an alias, which just creates a new virtual environment like this, and then sources it. So now you see here is a virtual environment created. And you can install this. Again, if you have an alias, it's nice. I don't remember the commands, like pip install -r requirements. So now we can run this and see the styling. Okay. It's painful to see. But it worked, okay? My goodness. I think that every time I ask, I tried this 3 times and they are all, I think the wild word is not the way. Okay, so important things now. What happened? If I now do git status, now we see things that I do not really want to track. This sys key or the PyCatch are things that are, 1 second. Okay. Because the virtual env should also appear. Okay. So these files, you do not want to add them to Git, right? When you are working, maybe you want to add all your current folder. If I now add all the things, we will have these files which are Python stuff, and you do not want to do this. So what you can do instead is the store minus stage. There is something called the git ignore. And this is as easy as it sounds. You just add here the things that you do not want Git to track. So we do not want the virtual environment file, we do not want the sys key, and we do not want the PyCatch. So now when you do git status, it no longer shows those files. Almost all repositories have one of these, and normally it's dependent on the language that you use to ignore Python-specific files, Django things, Golang things, TypeScript compiled stuff. So this is very convenient to be able to avoid polluting your git status. So you very clearly see, I change something or I don't change something, instead of having a huge list of my debug scripts, my test data, nodes, things that you don't want there. And it's very useful to communicate with other people because then they know what should not be in the repo. Okay, this is also a file, so you just have to commit it.
All the environment keys will also be part of this, right?
Yes, it's a file. We will just add it as a file. You can leave it like locally, it's fine, but then other people will not have the same git ignore. So the normal thing is to commit the git ignore. Yeah. Okay. Questions so far?
I did not catch why do we need to commit git ignore?
Why do we need it?
Yeah, I mean,
so,
it's sorry, you continue.
So git ignore, for example, if you have images or you have things that you don't want to go into the repository, it's just a convenient way of telling it, do not bother me, because otherwise it will tell you, you have this untracked file, you have this other thing. It's like, I don't care. I know I have this thing. It's very common. For example, if you have in FastHTML, you will have normally a data directory, and you do not want this so for example, you will have the data is here. So you do not want to commit this, specifically because if you commit, you can replace the one in production or whatever. So you say their data should not go into into the repository, and then you make sure that you not commit things.
Yeah, that I understood. But do we have to separately use the command commit git ignore to like ensure whatever is in the git ignore file is ignored by git?
So the question is if you have to commit git ignore to the git.
Yeah, do we have to commit it separately? Or
No,
otherwise
if the way which works is Git will check your current repo. If there is a git ignore, it will follow the rules. So whether it's in Git or not, it doesn't really matter. But if you commit it to Git, it means that anyone downloading your code will have the same git ignore. So it's convenient. It's a convenient way. Also, for example, if I'm collaborating with another person, when I clone or download their project, if I check the git ignore, I can understand, oh, okay, these things are not supposed to be in there. Or sometimes I will run someone else's code, and this code will generate test data that I don't really want to see. I just want to see the results. So then all these things are hidden from me in a convenient way. Otherwise, oh, do I have to check this? What is this files? It's just a convenience.
Got it. Thanks.
And this makes more sense because now what we can do is there's a version here. We'll add. So now we will improve this a bit, and we will add OAuth. OAuth is the typical login with Google button, right? So we will add this to our application. If you open here, for example, you can see as you can see, I completely overwrote this main.py. So it's a completely different file. But because Git changes, tracks files by lines, you can actually see this. In red was what I had before. This was our basic application, FastHTML demo, Git workshop. It's what was here. And in green, you can see what is the new, what I copied. So this thing I copied has a new index that will just show the email of the person. It has a login screen, and it has these small things required for OAuth. Make sense? Additionally, now we have to install also Monster UI. So let's do that. And now instead, we have login with Google, right? This will not work, invalid client, because we have to add our secrets here. And this is kind of all the git ignore thing was getting here. Because if you commit things and you push them to a public place, you do not want your keys. This is very important. Like you should never push your keys. And actually I was trying this before the call, and now you cannot even push your Google keys. GitHub will refuse. It's like, hey, they are secrets here. Do not push this. So how do we do this? Because we want to be able to share our code, for example, with other FastHTML students, but we don't want to push this. So the way that you normally do this in Python is by using environment variables. Do people know about environment variables? I assume yes. If not, you can ask. So let's add this version so we can see the changes with basic OAuth. And then so now this new version, instead of hard coding the secrets here, we get them from the environment. There's two ways to set them. One would be to just do this, export in the command line, and then you would run the main.py normally, like a Python main.py. But this is not convenient to track. So what is almost standard across many of the industry and many languages is to have what is called a .env file. These kind of files look like this. They are just very simple. This env.file file has the name of the environment variable and what is the value, the name and the value. And then almost all languages have a library to load them. In the case of Python, it's called load.env, which is very straightforward naming. And what this will do is it will check your current directory and load the .env file, and each variable will be set as an environment variable. It makes sense? Okay. So I'm going to copy the other one safely. So now the .env should be loading this environment variable with the correct Google keys. We will have to install .env also. It's already installed. Let's see. So now we see the credentials were okay. And if you open this, now it says your email and log out. Very easy. With this, you already have working OAuth, which is very convenient. Honestly, I have implemented this in other languages, and the FastHTML one is by far the best. So similarly to the git ignore, it's very common to commit a git example, like a .env example, for example. That way, other people, when they open your repository, they will not have the secrets. But if you want to use this demo, then you can go, oh, okay, to make this demo run, I need to copy this .env.example as a .env and put my values there. It's very common for keys to send the emails, Google credentials, everything that your app needs is in one place. And then people know very fast how to do it. Okay.
So it's like a template of the .env file.
Exactly. Some people call it .env.local, .env, like the name is not a standard. You can call it whatever, but it's quite common. I've seen .env.example, .env.local, and stuff like that. You can even have one for testing or different things, because here, by default, it will load the .env, but you can also add a route like a local, or if you want to test something, you do that, or production, and then you can have different files. But I rarely need this. For FastHTML in general, .env is more than enough. Okay, so.
And then like the .env file, which has keys, that goes to git ignore, and the other one does not.
Yes, exactly. That's a good point. So let's do that, because that's clearly the thing that you do not want to commit. Okay. So now we have the example. We can add all the untracked files, but we do not add the actual keys.
And git add -u, it commits all the files?
Commits all the untracked files. It means all the changes that are here, commit them. For example, let me show you something. These don't look at this, because this is too much to explain. But for example, here we have restore stage. Let's see. It restore stage like this. Okay, so if you see env.example was not in the repository before, right? So this is an untracked file. Sorry, actually, it's a good point. -u means updated, not untracked. It's completely the opposite. My bad. So if I do git add -u means add all the updated files to the staging. So if I do this, the env.example is actually not added, because it's like, okay, I added only the files that have been changed. But if you have new files, it's up to you to add them.
So we have to individually specify which new files also has to be committed.
Yeah.
Okay.
This, I would not worry too much about many commands, because, for example, I use -u often. Colleagues of mine never use -u. Some people do git add dot. So there's plenty of ways to do it. And actually now many times I already don't even use git add. I just open here and you can see changes, stage changes, which is very convenient. And you can hear, okay, so here I can on stage change, okay? So I on stage, I don't need status. This change is no longer. Makes sense? So it's very convenient now to click here and you can see what you added in it. These are the changes, okay? This is new. This added Monster UI. And here I added .env. So nowadays you can even completely bypass the command line if you want. You can just use this UI. And I know a lot of people, my previous boss only used the UI, never used the command line. So it's perfectly fine.
Interesting.
Okay. So yeah, everything. So now let's go to this part. Let's actually push these changes to our repository, because as we said, if our computer is fucked up or we remove something, we lose everything. So the way to do this is you can come to GitHub. GitHub is free. And you can create a new repository here. So new repository, we will call it Git demo. There's a lot of things that you can add. Like now, see, it already suggests you, hey, which Git ignore do you want? Are you working with Python? Are you working with, it tells you which language. So it will use a default Git ignore for you. You can also add a license and it has many things. But for us, we don't want anything. Here is an important thing. Do you want this to be public so anyone can see, or private, which only you will see? Even if it's private, it's good not to push keys, because you will be trusting Microsoft and GitHub employees. It's better not to do it, right? So do not commit things. But here we can create the repository, and this repository will have a link. This is the important link. Here it looks a bit weird, but it's just a URL. Actually, this is better because it can use SSH and it can bypass having to add your password. If you use HTTPS, you might have to enter your GitHub password anytime. You will, if you follow Git immersion, it will tell you how to set this up, if you want to avoid having to use password and many of these things. So what we want is to copy this. And here we call this remote. So this is exactly what we are going to do. We are going to say git remote. And we will add an origin that is going to be this. This is telling you, okay, now we have a remote repository and we will call it origin. This name can be GitHub, whatever, but it's convention to call it origin. And yeah, you will rarely have more than one remote, so it's fine. Okay, if we do git hist, we have all these commits, right? And there is only our local repository pointing to the main branch. So now what we can do is like we can push our changes, as we said. We push to the, we push our changes to the origin, to the GitHub repository, and we push our main branch. So now it says, okay, checking objects, it counting how many objects, it's compressing some stuff. And then if we go here, this was empty. If you refresh, now we have this. You can check all the commits here more conveniently. You can check also graph. There should be a graph around inside maybe. Network, I think. You can explore GitHub. It has so many features, like how many contributors are there, who was contributing, how many commits, and many different things. See, here we can see a graph. Okay, so very good. We did this. We did this. Okay. Any questions so far?
What's the difference between the main branch and like the other thing?
So the main branch, okay, we can do that. Let's say, let's do this change. I actually don't like this change at all. Let's try to do it following a stripe styling. Mosquito season. Okay. So this main branch is if you and me are collaborating, if we are pushing changes, they will go one on top of the other. And sometimes if we modify the same line, because Git tracks lines, there will be a conflict. Git will say, hey, you two change the same line. I don't know what to do. So what is common is to have different branches. So you will have your own branch and I have my own branch. We do changes and at some point we will have to decide which changes go in. Okay, and it's very convenient, for example, also to try different approaches. Normally, the way this normally works is you have a main branch, and then when you implement a new feature, like let's add to solve it this new feature, you create a branch with the name of that feature, you develop, and when it's ready, you merge back. So you can have many commits and versions while you develop the feature, but it's not yet ready, so you don't want to push it. So for this, for example, now, I will create a different branch where we can have a different kind of CSS. And then you can quickly compare because you can change between them. Okay, so now we see this is Cloud Code way of showing the changes, which is essentially, as you can see, a Git diff. So let's accept this, yes. And now we have these changes. But let's say I do not want to lose my current styling. I want to check something else. So you can do checkout and create a new branch. There's many different syntaxes. You can do git branch, git checkout -v. But this will create a new branch called the stripes styling. Okay, and now if we look, we see, okay, there's a new branch called the stripe styling, and there's also main. But now I haven't had any change, so they all show the same. But now if I commit this, it add style, it style, stripe styling. See, now there is a new branch here. It doesn't look like a branch because main has not been changed. So this is building on top. But if I now go to main, so git checkout main, well, 1 second. First, if I do git status, now you can see on branch, the stripe styling. If I do git checkout main, I do git status, on branch main, right? And if I go to the hist, now the head is pointing here. So we are back to the original styling. So now, for example, if I go here and I refresh, I have this. Sorry. Okay, so if I go to Stripe, actually, now you can refresh, and I have a completely different styling. So this way is very convenient. You can have multiple, and you push, and then you let other people, okay, I want to change between different styles. Or for example, it's very common, you will open a branch, you have some working code, you will open a branch and you tell Cloud Code or Cursor, implement this new feature. And after 20 minutes, it's like, okay, this is not going to work. This is a very bad idea. So you can just delete that branch, or you leave it in the branch like, okay, maybe at some point I will have a look, but now I don't want it. So I will leave it there and keep working on my own stuff. Make sense? So now what we can do is like, we can deploy this to Flash. This step I'm doing now is not necessary for you. You just need to do Flash deploy after registering. And if we go here, ideally, it's going to fail because have you ever used Flash?
I have.
Okay, very good. Flash is very convenient to deploy. So it just deploys whatever is in your current folder. It normally requires a main.py and I think a requirements.txt, but I'm not sure if the requirements is necessary. But we can go here, and if I go to the logs, we can see, oh, what is the problem? The client ID, right? The famous client ID. So how do we do this? The way to do this in Flash is, so Flash is FastHTML way of deploying, and it's what I really suggest. It's extremely convenient. So how do we push these environment variables to Flash? The way to do this, if you go to the docs, which are short, concise, and very recommended, is how to add environment variables. Using environment variables in your own apps, you have to create a flash.env, add your environment variables like this, and then access them from the environment. We are already accessing them from the environment, so the only thing we need to do is adjust our environment to be a flash.env. It's almost the same. The only difference is that you need to export them. So let's unsafely do this. So we copy our environment file into a Flash environment, and the Flash environment, let me open it here. The only thing we need to do is export. Clear so far? So once you save this, it's as easy as Flash deploy. They will pick up these variables. You will see that this will build again. And ideally, you go here. It should work. That's it. So for those of you that don't work much or don't deploy too much, this is very fast. Like deployment in AWS, things like this can take much more, but Railway and Plage are very, very fast. So 5-10 seconds it's amazing. So if we click here, now we can log in. And we have this one looks much better. We have our header, our Git for FastHTML, and we can log out. Okay, so this was the main thing I wanted to discuss. There's a bit more thing, but the time is a bit tight. So I don't know if you prefer to make questions, if you want some more comments, up to you. Yeah, I think that's it, because we can discuss a bit more branches that I think we already did it. The push and pull request, what not to commit, we already discussed. Yeah, as I said, there's many different aliases. For example, now for pushing, I use GGP, which is from a library. But yeah.
I had one question. So like in Railway, like when I was initially doing, it also asked me to like push through GitHub or like through some other channel, right?
Mm-hmm.
So for like keeping the versioning of the apps also saved. Do you have any comment on that?
So say again, what's the question?
Instead of directly deploying on Railway or Flash, is it better to deploy it through GitHub?
So, okay, so GitHub will track the changes in your code, but it will not deploy to Flash. You can set up GitHub to deploy automatically. So whenever you push, deploy this to Flash. You can do that with CI/CD, but it's I don't want to get into that because it might be a bit more tricky. But essentially, if I now do this, let's say, let's push also the stripe styling branch. Okay, so now you can see in GitHub, we have two branches, main and stripe styling. And it's telling you, okay, this one has one more commit than the main. Okay, but if I now go to Git main and I do + deploy, what will happen is that we will have the old styling here, right? And this has nothing to do with what is the status in GitHub. GitHub just tracks your changes, but Flash deploys what is in your folder at the moment of deployment.
Right.
Make sense?
So we had to always deploy to terminal, the local repository, and parallelly keep the track of changes on GitHub, you mean?
Exactly. So I think that you were doing this. What you can do is, like, for example, if you are doing things on Solvit, and then you want to deploy them, well, actually from Solvit you can deploy because you can run + deploy, I think. I have not tried that. But if you don't want to deploy from Solvit, let's say, or you have another computer, you can push the changes to GitHub and then you pull them locally, and from your local computer you do + deploy.
Okay. Mm-hmm.
You can definitely set it up because, yeah.
Yeah, I was just going to say, one way to think about it is if you just do an upgrade directly from the command prompt to Flash, it's going to be quicker than doing an upload to GitHub and then transferring it over to, can't do it in Splash, but if you did it to Railway, because you've got an option to do that.
Yeah.
So you might not want to git commit something, but you might want to test it against. So then you can just do the upload direct. It's far, far quicker.
Yeah. Personally, and in general, when you are collaborating with more people, the advantage of making GitHub deploy your changes is that if every time that you push into a main branch, the changes are deployed, then you always know what is going to be in your website. The only problem with Flash running it locally is that then if I now go to GitHub, if someone checks here, they cannot know what is in Flash. Is it stripe styling or is it main? Because I have run it locally. And I have this, for example, I have a demo, well, no, a demo, no, an app that I use that is exactly what I showed you, but a bit more complex. You see it has the styles, the git ignore, everything is here, and this is completely public. but you cannot know what is deployed. The app is here, but you are not really sure if it's the latest version or not. You have to do it manually. The other way, you know, okay, every time I push it will be deployed and I forget about it. And a nice thing that you can see also, not commit, if you want to use a custom domain, what you would do is like in this splash here, this is Dazzling Meteor Connects is the name that you see here.
Yeah.
So the only difference for an application like mine here, like Compound Habits, is that here you will have this. Compound habits.me. And Splash will work the same. You just have to do some small setup, but then every time you deploy, it will deploy to this custom URL. And it's a breeze to do. Like you have here that custom domains thing. You just have to do this thing I mentioned. And add a small, should be somewhere. Yeah, and you will have to set these details in your DNS.
And to retrieve the file from GitHub, the whatever is like most recent, we need to use git pull, right?
Yes, exactly. So actually, you can modify. It's rarely recommended, but you can do. For example, I can add a readme here, right? Like, is an online readme created? Doesn't make much sense. So now this has been committed to the main branch, right? If we go here in commits, you will see create readme, right? But if I go locally, status, there's nothing here. And if I do git log, the latest is .env, which is this. So now, if you can do two things, you can say like, get whatever you want there and pull it, which is what you will normally do, which is git pull from origin. The main branch is push origin main, pull origin main. This is what you will do, but I will do it in 2 steps so we can see what's happening. If you do git fetch, it will say like, just give me information. I don't want to download anything. So if I now do git hist, you see what is happening here is that like, okay, we have the head, the local head, your current working directory is here. And this is the main branch. But now there is an origin branch, which is the one in repository in GitHub. And this one has a new commit that you do not have. And in addition, because now this branch has a new commit, the other branch is no longer going after it. So it's literally a branch. You can see these, they are now diverging. So they are now 2 different branches. So if I now do the git pull origin main, that is what you will normally do, you will see, okay, I am moving your head forward. And now we are in this new commit, which has a new file. And if you do git hist, you will see that now our head points to the main, and the main is at the same commit than what is in GitHub. Make sense? And now the final thing is like, if I want, okay, the changes from Stripe look much better, right? Like, this is horrible. So then we can say, okay, I want to merge the other branch. This will ask you to add a description like, oh, I am merging this branch, but normally you can just leave it. This is the commit message. So now it's like, okay, we have merged these 2 branches. And if we open this, you will see a new commit. And this new commit is the result of this branch and the other branch. The changes went together. And you can see that here it's saying like, hey, in GitHub, you still have your old Stripe styling branch, right? So the branch in here has not changed. And the branch for main has not changed either, right? If I go to here, there is wait, here I go to the main branch. The style is the second commit. It has not been pushed. So if I now do it push origin main, now here we will have, did I do something wrong? Stripe styling, yeah. And the time is when you committed, not when you pushed, right? And if you go here, you will see something a bit nicer. You can see how it splits and how it merges back. If you look at, well, these loads, I will open also. So see, for example, this is FastHTML, and you can see here how they develop features. This is the main branch. So here, for example, Eric created a new branch to work on something, support this thing, fix URL. And at some point he was happy with this. So Jeremy merged this, merge, pull request, something. And now from this version, they started working on something else. And these are, for example, branches that someone opened, but they were never merged. You can just, now that you know, you can explore this much more conveniently. Here, see, all of these branches are, oh, I'm fixing this thing, I'm fixing this other thing. Once you merge them, you can delete them, you can leave them. This is up to you. And also one last thing is like tags is a way to say, okay, this is a special version. This is, for example, a release. So now let's say we are happy with this and we are going to tag it and say this is version 001. So now we have a tag here. And it's just a new label on a commit. It's nothing else than that. You can do it push, I don't know the syntax, origin main minus tag or something like that, I think. Okay. So now if I go to my own Git repo, Git demo, was it? You will see there's one tag, there's one release here. And the advantage of tags is that you can check out them. So if you are in latest branch, oh, what happened in version 2? You can do git checkout version 2, and then you can explore whatever happened there. Or if there was a problem, then you can go there, try to fix it, and then merge it back. But I think that's already a lot.
So it's like checkpoints.
Yes, exactly. Checkpoints is the perfect description. Yeah. It's just a way to give name to a commit. It's nothing else than a name. And you can, Here, for example, GitHub does nice things for you and you have the source code. So people can come here, click and download whatever you have. When you install packages, it's very common for them to say, go to releases and click the latest release. I don't know. Now a good example, maybe FFR Python. Let's see. So here, for example, this is a random library, not related, but I think that they have binaries. So it's convenient. No. Okay, let's see. Maybe not Python version. Well, no, not something open source, maybe. If you have an open source application that you have to install with double click, many times in the release, you will have the binary that you can do download. That was the point. So, any question? Happy to answer also questions offline. And wait, let me, considering that you are FastHTML students, I really suggest, again, to go into Git immersion. It's command line and it will set you up very easily. You will know how to put your name in commits, how all of these things work, and sensible things like line endings that you will do once and forget, but it needs to be done, even if you use cursor. Second, if you want to explore someone else's code, you can just clone it like this. For example, FastHTML now FastHTML is a big project, but there's small libraries like FastStripe or FastSlide that are quite small. So it's very convenient to be able to, at some point, navigate them. So you can just clone them locally. So let's do this. So git clone, right? And now I go into FastHTML and I do git status. Of course, there's nothing. But if I do git hist, these are all the changes from Answer AI. And this is what we were seeing in the web interface.
Mm-hmm.
These are those commits. So you can just have a look. If there's any, so there's, for example, this tag. Instead of this, let's check out the previous one. Let's see if, 11.0. See? So now we are in this tag. Not switching to 0.11, so you can explore. Although a very small trick is that nowadays you can just click dot. If you click dot in GitHub, it will open a web editor, and it's a VS Code because it's Microsoft. So cloning is no longer that necessary. See, this is literally the same I have here. And you have, all the things we showed, and you even have Copilot around somewhere. So if you are exploring GitHub repositories and you want to check something, or for example, you want to do Command F and find, I don't know, whatever, you can use search functions. And yeah, explore GitHub repos. When you look into them, you will get more familiar. You will see how people use them, how they collaborate. And now AI can do almost all of these things for you, but it's very easy for them to fuck up sometimes. So I suggest to get the basic structure in your head, like, okay, staging, committing, pushing, because otherwise at some point we'll do something weird and then you'll say, oh, okay, well, what are you doing? Like, do not do this, because they have been known to delete things that they should not. But yeah, my advice is like, commit things, let AI run while doing changes. If you like it, you commit it. If you don't like it, you delete it.
Mm-hmm.
And that's it.
So instead of asking AI to commit changes on our behalf, like we should commit it, or like we should tell it the command to do it for us.
So I almost always commit manually, but last week I started to use Cloud Code, and they know perfectly well Git. So you can tell it like, modify the title color and commit it and push it to origin main. And it will do everything for you. Wait, let's do this in YOLO mode. So this means do not ask for confirmation, just go. So let's close this so we see full screen. See, find and modify the color, commit and push. They know Git has not changed in many years. They have added new features, but the core has not changed, and it's always backwards compatible. So AI, it's perfect for AI. They know perfectly well how to use it. They might fuck up sometimes still, but the commands are pretty well known.
Mm-hmm.
Can you restrict certain commands for Git on Claude Code? So don't use, I don't know, Git delete or whatever it's Git remove.
If I rarely let Cloud Code use Git. Now I'm starting, because it's convenient for it to write the commit message. So sometimes I'm starting to do it, but this has been last week. In general, I do it all myself so far. Was that answering the question?
The trust is getting more, but yeah, there's some things I just don't trust it for. And deletes the ones I don't. So yeah, I just wonder whether you can restrict certain commands.
Yeah. So see, it did git add, it did git commit, and then git push. And if we go here, you will see bump. It just sorry, I'm in the wrong repository. Wait. So if we go here, you see change title color In this case, it's not very necessary, but the good thing when you're working in a big code base and you have a lot of changes in one commit, it's very useful to say like, hey, create a commit and add a big description of what you change so other people can see like the full description, not just a single sentence, because you can do a longer description.
Do you modify your workflow? Do you modify the Git message that they create, or do you let it write it and then just edit it, or do you just go, nah, I trust you?
So I have done it, I think, only 7 times I have committed, I think. The first 2, 3, I copied it manually and removed a bit. The last 2, it was quite good, and I just let it commit. But originally, it has a tendency to say done by Cloud Code. So first I deleted it. But now I have it in the Cloud MD. So the last 2, 3 were quite okay. But in general, it's quite verbose. I don't love it. If it's a small change, well, a small change. If it's something that is not too complex and the description is fine, then I will go with it. But it's not the case. When it's something very important, I try to review it myself. Okay, so I guess thanks for hosting this, Aditya. I hope it was useful. I don't know if it was too slow, too fast, or useful, but I'm gonna push these changes. And personally, the GitHub, like the OAuth thing with Google is extremely useful for me. I use it in all my projects. So I suggest you just, whenever you have to start something, it's so easy to just have this small login stuff.
Thanks, Paul, for walking us through so patiently.
Yeah, it was actually very useful since just started learning Git, using Git. This is like a really picture perfect way that you have explained everything. Yeah.
Happy to hear. Again, offline, feel free to send me questions. And this is something that with the time you will just get used to it, and it's quite convenient. And every person has a different flow. Every company has a different flow. There's so many different strategies to merge, to write messages, there's so many different things. So yeah.
Thank you so much.
Okay, then see you soon.
See ya. Bye.
Bye everyone.